All right. Okay. So what we'll do today is finish section 8.3, and that's dealing with percentiles and box plots and outliers. Okay, so I get somebody coming in. Okay. Now, already we talked about percentiles. Okay. And we had a given number. We want to convert that to a percentile. And I gave you a procedure of how to convert a number and determine the percentile that number is in based on a data set that's given to you. And then we work backwards by doing this. We had a percentile and we want to find out the data value that corresponds to that particular percentile. And I gave you a procedure to do that as well. And then we talked about the 5-number summary. We just kind of briefly talked about that. And it consisted of 5 things: the lowest number, or the minimum value, of course, then the first quartile, which separates the bottom 25% from the top 75%, that's Q1. The median is the second quartile, or Q2, or the median. That's, of course, the middle number of a sorted data set. And by the way, it has to be sorted before you can do the 5-number sum to begin with. And the third quartile, Q3, that separates the bottom 75% from the top 25%, and then the highest number, which is your maximum value. Okay. Now, let's look at, if it will let me. Okay. So here, the next example that we will look at deals with finding the 5-number summary for a data set. All right, like in this one. Hank Aaron played baseball for the Atlanta Braves for 23 seasons from 1954 to 1976. The table shows the number of home runs he hit each year, from the lowest to the highest. And here I want to find that 5-number summary from this data set that we have here. Okay, and notice that the data set is sorted from least to greatest. Okay. So as you can see here, the lowest value is 10. So the minimum, or the min, is 10. That's the lowest value. Okay, now for the first quartile, the second quartile, and the third quartile, they used, of course, I is equal to P over 100 times N. They're finding the location. So, in fact, let me go ahead and do this. Okay.
You can press the 3 little dots at the top of your little picture.
Okay, thank you.
No, on your little picture where it shows you, it has 3 dots. You can press pin video. Pin. Yeah.
Okay, there we go. All right, so if you recall Q2 of the second quartile, well, let's see. Let's start with Q1. That's the 25th percentile. So here we have to use I is equal to P over 100 times N. And we looked at 23 of these data values that we have here. Yeah, 23. So this would be like 25 over 100 times 3. So if I do 25, I'm getting 3 from, it should be 23. Okay, for N. So in this case here, if I do 25 divided by 100 and then multiply that by 23, I'm going to get something like 5.75, which is actually a decimal. So I need to round that number up to the next larger number, larger whole number. That would be 6. Okay. So in this case here, the 6th number represents Q1. That's the first quartile. So Q1 was 26. And then the median, we just do Q2, which is the 50th percentile. So here, I will be equal to P, which is 50, divided by 100 times 23. So half of 23, that's 11.5. And again, we round this up to the next larger whole number, which is 12. So the 12th number ends up being 34. Okay. So that 12th number is 34, because you have to count 6, 8, 10, 12. That's the 12th number, 34. And then Q3, here we do the 75th percentile. And of course, that's going to be 75 divided by 100 times 23. And we have to round 17.25 up to 18. So this will be, so we have to look for the 18th number in this data set. So that's the 12, 13, 14, 15, 16, 17, 18. That's 44. So Q3 is 44. And then the highest value, which is your max, that's going to be 47. Okay. All right, now we have those have our 5-number summary, which is this. And it also can be represented in a table like this, where the mean is 10, Q1 is 26, Q2 is 34, Q3 is 44, and the max is 47. All right, any questions on this particular example? And for those who did in it, then there it is with Q3, how I did that. All right, so now let's look at problem number 23 on page 473, if I can get to it. There we go. Let's say I want to find the 5-number summary for this given data. And here is that entire data set.
It also has 23 numbers.
Yeah. Okay, so N is going to be 23. What a coincidence. And I keep writing 3 each time. It should be 23. Okay, here we go. All right, so now, right off the top, I can tell you right now, this is sorted from least to greatest. So this is going to be quite easy. What would be the minimum? 18. And what's the maximum? Okay, so already we have our min and our max, which is 18 for the min. I'm going to have Q1 here, Q2, which is of course our median, Q3, and then the max, which is in this case 82. So all we have to do here is find out what Q1 and Q2 and Q3 are going to be.
Should we reuse the same math and just count the numbers again?
Yeah. Because that means I is equal to, well, you have to think of this as the 25th percentile for Q1. And here, our I is going to be that 25. Hold on. I is equal to P, which is 25, divided by 100, times N, which is 23. And I think we did this before. That was 5.75. Round that up, it would be 6. So we have to find the 6th number in that data set. And what would that be? 31. There it is. So here, the 31st number, the 6th number is 31. I'm just boxing in the numbers that are in our 5-number summary. And then for Q2, that's of course the 50th percentile. So we do 50 divided by 100 times 23. You'll get 11.5, so that means we have to round this up to 12. So we look for the 12th number in that data set, which is, okay. So that'll be 40, because the first row has 10, then the 11th, then the 12th, that will be 40. So 40 is the number that represents the 50th percentile, or the median of this entire data set. And then for Q3, that's the 75th percentile. So that's I is equal to 75 over 100 times 23. And I came out, I get 17.25, but we have to round this up to the 18th number. So the 18th number in that data set would be how much? 61? Yeah. Okay. So these numbers that I have boxed in are, that represents the 5-number summary. Any questions about finding the 5-number summary? Okay. All right. So now the next thing we'll look at is taking this 5-number summary and constructing what they call a box plot, or in some cases, a box and whisker plot. Okay. A box plot is a visual representation of the 5-number summary. And in this figure that you see here, it shows a box plot corresponding to the 5-number summary of the annual number of home runs hit by Hank Aaron over his 23-year career. Okay, so this is the box plot and what it looks like. Here they have a number line from 0 to 50, and they marked out. This part right here represents the minimum. And then here's what makes up the box. The first quartile, the second quartile, and the third quartile. The first vertical line in the box represents the first quartile. This line inside the box is the median, or the second quartile. And this line, excuse me, this line right here represents Q3, or the 75th percentile. This line right here at the tail end, that's the highest value. And it's separated by what they call whiskers. This whisker separates the minimum value from the first quartile. And this whisker on the end separates the maximum value from the third quartile. Okay. So that's what a box and whisker plot looks like. So here are the quartiles, which are Q1 and Q3, where Q1 is 26 and Q3 is 44. Those correspond to the edges of the box. The vertical line in the box corresponds to the median, and that's Q2, which is 34. The endpoints of the whiskers correspond to the lowest value and the highest value. Those are your extreme values, okay, as I just mentioned. Let's look at this one, problem number 1 on page 471. All we have to do there is just find the file number summary for the data summarized by the following box plot. Okay, so here's our box plot here, and we want to find the file number summary. So in other words, we're looking for the minimum. We want to identify Q1, Q2 for the median, Q3, and the maximum. All right. So what would be the minimum here? It'd be 14, because here's this line right here, which is our extreme value on the left. That's 14. That's your minimum. And what would Q1 be? It'd be 20. This is the first line in that box, and it corresponds to the number 20. And what would Q2 be, or the median? Be 28. So here, this line inside the box represents your median for Q2, and it corresponds to the number 28. And then what would Q3 be? That'd be 30. Here's what Q3 is, corresponds to the number 30. And finally, what's your maximum? 32. Okay, that's this line right here. That corresponds to 32. So this is what the file number summary is. Minimum is 14, Q1 is 20, Q2 is 28, Q3, 30, and 32 is your max. Okay. Any questions about problem number 1? Okay. Take a look at problem number 2. And it says here the file number summary for the number of phone calls per hour for a technical support hotline is. 4, 12, 15, 20, and 22. Draw the corresponding box plot. Be sure to use appropriate tick marks on the axis. Okay. So that's the data. That's actually the file number summary. So we're going to take that and construct the box plot. Okay. So here is how we're going to do that box plot. I'm going to draw a number line like this. Let's see here. And I'm going to start with 0. Let me see if I can do this in twos. Groups of 2, like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Probably easier to do it that way. And from that, we can construct that box plot. Okay. What's the minimum?
4 by 4.
It'd be 4. Okay. That's the minimum. And what's Q1? 12. And Q2, 15. Q3, and the max has to be 22. Okay. So we're going to find 4. So here's 4 right here. It's a minimum, so I'm going to draw a line like this at 4. That's going to be the whisker that's going to be connected to the minimum value to Q1, which is in this case 12. So I'm going to draw a longer line here. That's going to be part of the box there. And I'm going to connect this to Q1. That's the whisker. Q2, which is the median, that's 15. Well, that's halfway between 14 and 16, so I'm going to draw an equally long line there. And then Q3, that would be 20. Now keep in mind, Q1, Q2, and Q3 make up the box. So there's the box right there. The maximum is 22. So if it's 22, I'm going to draw a smaller line there and connect the whisker to that. Okay. So this is what the box plot looks like for this 5-number summary. Any questions about problem number 2? Just creating that box plot just from the 5-number summary. Okay, now let's say we had a data set like this. Software cameras is important for organizing and editing digital pictures. A photographer ranked cameras sold with software using a numerical score from 0 to 100. Here we want to take this data set and draw an appropriate box plot of this data. All right, now already we can see that we're going to have to take this data set and and sorted in numerical order from least to greatest. So I'm just going to copy down this data set that we have here. Okay. So now we need to put this in numerical order from least to greatest before we do anything. All right. What is the smallest number? 15. And then what's next after 15?
Looks like 32.
32. And then what's next? 33. And then
36.
36. And then the next one is 43. And I think 48 is next. What's next?
48 and
50. And
62.
62. And 75 twice. Which is actually the mode, by the way, 75. Okay. In this case, there are 10, so that means, yeah, there better be 10 when they're sorted from least to greatest. Okay. Now, we need our 5-number summary. And that's, of course, the min, Q1, Q2, Q3, and the max. What's the minimum? 15, and what's your maximum? 75. So that's easy. All right, now, for Q1, I'm gonna box these in. Q1 is, of course, the 25th percentile. So the position that the first quartile is in, we can find that out by taking that 25, divide that by 100, multiply that by 10. And if we do 25 divided by 100 times 10, we're going to get what? 2.5. And that's a decimal. That means I need to round it up to the third number. So it's going to be the third number that we're looking for in this sorted data. What's the third number? 33. That represents Q1. Don't tell me. Okay. All right. Sorry about that. And I'm still recording. Good. All right, so 33 is a number that represents the first quartile. And now Q2. That's at 50 percentile, which means this is 50 divided by 100 times 10. How much? It's going to be 5. and it's a whole number. So not only do we need to look at the fifth number, we need to look at the sixth number as well and take the average of the two. In this sorted data set, the fifth number is 43, and the sixth number, 48. So here we have to, okay, half of it, I know this is going to be 91 divided by 2, or 45.5. That represents the second quartile, or the median. Okay. And then for Q3, which is a 75th percentile, that's 75 divided by 100 times 10. And 75 divided by 100 times 10, I know that's 7.5. We round it up to 8. So the 8th number in that data set is 62. All right, so the minimum is 15, the Q1 is 33, Q2, or the median, is 45.5, Q3 is 62, and the max is 75. All right, now let's take all of this and construct a box plot for that. I might need to do this over just a little bit. So now, this is what I did. Here's 0, and I did this as 10, 20, 30, 40, 50, 60, up to 70, because let me expand this a bit. Because I went up to 80. Yeah. So now here's our box plot. All right, the minimum was 15. That's halfway between 10 and 20, so I'm gonna draw a small line there. That's gonna represent part of the whisker. And Q1 is 33, so we're gonna have to kind of guess where 33 is. It's a little bit past 30. So I'm gonna put that longer line that starts the box right here. And then Q2 was 45.5. Let's see. I know 45 is halfway between 40 and 50, so let's say about right here. That's your median. 62 is Q3. That's going to be a little bit past 60. And these three longer lines here represent the box. I'm going to connect the whisker to right here. Connected it from the minimum to Q1. And then finally, 75. What's the max? Halfway between 70 and 80. And that's going to be connected to Q3 like this. So this is what the box plot looks like. Okay. All right, any questions about problem number 23? Okay, so here you have to first sort the data set from the least to greatest, and then do your file number summary by finding the min and the max first, and then use I is equal to P over 100 times N to get Q1, Q2, and Q3, and then draw the box plot from there. All right, now there is a another type of box plot that we will look at in this section. That is, if I can get to this slide. Okay. We're going to try to detect outliers and create outlier box plots. Now, what is an outlier? That's on the next slide. An outlier is a number that is much smaller or much larger than other numbers in the data set. Okay, that's going to be those numbers far away, either to the right or far away to the left. Okay. Now there are several possible causes of outliers. Now an outlier may represent a rare occurrence because of diversity in chance. Like in this case, the Guinness World Records recognizes Robert Pershing Quartiles as the tallest man in the world at 8 feet 11.1 inches. That would definitely be an outlier. 8 feet 11.1 inches. An outlier may represent a malfunction in the equipment. Okay. An outlier should be identified because, by definition, they are extremely unusual and do warrant further study. And later on, we're going to be talking about usual and unusual. I think we already talked about this before. Usual and unusual. When we were dealing with mean absolute deviation. All right, so here is how we can use quartiles to identify outliers. Okay, so here we're going to let the measurement y belong to a collection of numbers with quartiles Q1 and Q3 and IQR, which is short for inner quartile range. That's equal to Q3 minus Q1. Inner quartile range is going to be the difference between those two quartiles, Q3 and Q1. Okay. Now, here are the conditions here. If the measurement y is less than 1.5, Q1 times 1.5 times that inner quartile range, what you do there is take the inner quartile range multiplied by 1.5, subtract it from whatever Q1 is. If that y value is less than that, then that means you have an outlier. That means that the y value or the y measurement will be extremely low. And for a y value to be extremely high, that means, what this is saying is this: the y value has to be greater than the value of Q3 plus 1.5 times the inner quartile range. So you'll do the inner quartile range times 1.5, add that to Q3. And if that y value is greater than that, than that amount, then you have an outlier that is extremely high. And what that means is this: y is going to be much less than the first quartile, which is a 25th percentile. If it is, then you have an outlier. And also, if y is much greater than the third quartile, or the 75th percentile, then that y value will be an outlier. Okay. Now we're going to do a couple of these in class, But here, I want to show you an example. Let's say we want to draw a box plot of this data set and we want to use a mark such as a dot to indicate outliers, if any. And here's the data set. And as you can see, that data set is already sorted from least to greatest. So here we find the quartiles and the interquartile range. Okay. Now, I won't go through the I is equal to P over 100 times N business, but for the sake of time. But here you can just count how many data values you have. There are 15. So the IQR there would be 12. Q2, which is the median, that's 28. And then Q3 is 35. And to find the interquartile range, we just do Q3 minus Q1, 35 minus 12. That would give you 23. Okay. So here we have to choose endpoints of the whiskers that are not outliers. Okay. So here we're going to check for values that are extremely low using Q1 minus 1.5 times the IQR, the interquartile range. Your Q1 was 12, and then minus 1.5 times the interquartile range, that's 23. If you were to do this in the calculator, you'll get negative 22.5. So if there is a value that's less than negative 22.5, that means that data value is an outlier. Now, in this case, there aren't any. Here we don't have any negative values. We didn't have any negative values in that data set. So we don't have any extremely low values. So that means that the 3 would be the endpoint of that whisker, meaning that's going to be the minimum value when you do your box plot. Now, we check for those that are extremely high by using Q3 plus 1.5 times the interquartile range. Here, Q3 was 35. The interquartile range was 23. So we got 35 plus 1.5 times 23. Do this and then calculate, you'll get 69.5. So if we have any data values that are greater than 69.5, then we have an outlier. And based on that data set, we do. 69.5, that's less than 72. Actually, 72 is greater than 69.5. That means 72 would be your outlier. But in this case here, 38 will not be an outlier because that value is less than 69.5. So the 38 would be your maximum value. That would be the end point of that whisker. Okay. So on the next slide, that's where we draw the outlier box plot. Okay. So here it is. And that dot that you see on the far right represents our outlier for this data set. Okay. Now let's look at problem number 35 on page 474, parts A and B. All right, in this case, we're going to draw an outlier box plot for each data. Now here they're asking to use a circle for any outliers. Okay. All right, in this case here in part A, we got, actually, we got this paper right here. 21, 23, 44, 56, 67, 82, 115, 119, 125, 133, 240, 360. That's the data set, and we're going to draw an outlier box plot for this. Okay. Now notice already we have a sorted data set already from least to greatest. Okay. And notice I'm doing this min Q1, and then Q2, Q3, and then the max. Let's first find Q1, Q2, and Q3. Of course, Q1 represents the 25th percentile. So here, the I position would be 25th percentile divided by 100 times N. How many data values do we have here? It's 12. Okay. So 25 divided by 100 times 12 would give me 3. So in other words, I need to find for Q1 the third, and the fourth number, and divide by 2. What's the third number? 44. And what's the fourth number? 56. We're going to divide that by 2. So that means this is 100 divided by 2, which is 50. So 50 represents the first quartile. And then for Q2, that's the 50th percentile. So here, this is 50 divided by 100 times 12, which is how much? 6. And that's an even number. So the second quartile, it's a whole number. So it'll be the 6th and the 7th number. I'm going to get its average. What's the 6th number? 82. And what is the next number after that? 115. Divide that by 2. This will be 197 divided by 2, which is 98.5. So that's Q2. And then Q3. That's the 75th percentile. $75 divided by 100 times 12. That's going to be 9. So I need to look at the 9th and the 10th number and get its average for Q3. What's the 9th number in this data set? 125. And what's the 10th? 133. Divide that by 2. This will be 257 divided by 2. No, take that back, 258. So 258 divided by 2, 129. That's Q3. Okay. Now, I need to find out if I have any outliers in this data set. Okay. Now I need to find out if I have any extremely low values or extremely high values. So here IQR, let's find that out first. That's Q3 minus Q1. That's the inner quartile range. And Q3 in this case is 129. Minus Q1, that's 50. What's 129 minus 50? How much? 79. That's the inner quartile range. Okay. So now to find out if I have any extremely low values, I have to use this. I have to do Q1 minus 1.5 times the inner quartile range. Q1 minus 1.5 times the inner quartile range. In this case, my Q1 was 50 minus 1.5 times 79.
That 1.5, that's just part of the formula there.
Yeah, right. It's part of the formula. So what's 50 minus 1.5 times 79? Anyone? Yeah, that's what it is. Okay, yeah, that's okay, because you might get a negative. And that last example we did, it was negative. And in this case, there are no negative numbers in this data set. Okay. So what would be the minimum in this case? Has to be 21. Okay. So we're okay with that. Now let's look to see if there are any unusually high numbers in this data set. Okay, so let me draw a line here. This will be Q3 plus 1.5 times IQR. Okay. For unusually high, we have to use the Q3 plus 1.5 times the inner quartile range. Q3 is 129 plus 1.5 times the inner quartile range, which was 79. Yeah, 247. All right, 247.5. Now we need to find out what data values are greater than 247.5. 360 is the only data value that's greater than 247.5. That means our outlier is 360. Which means the maximum will have to be what? 240. Yeah, because 360 was the outlier, so that means 240 will have to be the maximum because 240 is less than 247.5. Okay. Questions how we got that? Okay. Now this file number summary that we have up here, we're going to do a box plot for that. Okay, so let me move this over so it can be seen. Let's see. Here. Okay. And the way I did this, let's see, starting with 0. This is 25, 50, 75, 100, 125, 150, 175, 200, 250, 225, 250, 275, 300, 325, 350, 375. Okay. So here's what the box plot looks like. The minimum was 21, which is less than 25. So here, I'm gonna draw a line right here. The Q1 is exactly 50. So I'm drawing a longer line there to represent part of the box. The Q2 is 98.5. That's about close to 100. So I'm gonna put it about right here. I'm gonna connect this from the minimum to Q1. And Q3, 129, a little bit past 125, so I'll put it about right here. This represents my box. The maximum is 240. That's way over here. Connecting Q3 to that maximum point. And the outlier, we said, was 360. This 350. I'm gonna say 360 is about right here. I'm gonna draw a dot there. That dot represents the outlier.
How many outliers can you have before it starts shifting the box?
I don't think there's any limit to how many outliers you can have. It all depends upon what your IQR is on the low end and on the high end. But unusually high or unusually low values. Okay. All right, any questions about part A? Okay. All right, I'm gonna have to stop right here, but I can open up the homework for section 8.3, and I'll do part B on Wednesday. Okay. So we'll just talk about, finish that last problem on the outlier box plot, and then we'll go into chapter 9 that deals with probability. Okay. Yes.
Do you mark dots for all outliers, or is it just the most things? If you have multiple outliers, do you mark them all?
No, you mark them all with dots.
Okay.
Mhm. Any other questions?
Can you give me the maximum of the IQ? What is it?
In a quartile range. All right, up here.
Inner, like inner.
Oh, inner. Oh, okay.
Yeah.
And we call it the IQR for short.
It expresses most of the numbers are in this range.
Okay. Because that's the first quartile, that's the second quartile, I mean, the third. That represents the middle 50%. Yeah,
I'm with you, I get it.
okay.
Which we had another season before. Well, and I'm like, I had no idea what he was talking about last year.
Okay. All right.
You remember last year, we was all starting to struggle.
So whenever we get the max, the number before the, not the max, that 360 number. In the
Which is
bottom down here,
Yeah, which is the outlier?
that's the outline.
That's the outlier.
That's
so that
gonna be the
means-
end number.
Yeah. The number before it will have to be your maximum number.
Would have to be the max, okay.
Yeah.